All right, hey guys, today I'm going to do some practice problems to show you the slip and slide method and kind of refresh your guys' memory on that. Remember, when factoring quadratics in standard form, and this is standard form here, ax squared plus bx plus c, right? Where c is just a constant term and a and b are the coefficients of the first and second term. And a lot of times we just have a equals 1, and that's just easy. You just pick two numbers that multiply together to get c, but add together to get b. But sometimes we have a number in here for a, like 3p squared minus 2p minus 5. Okay? And the slip and slide method, we take the a term and we multiply it by the c term. And we'll rewrite it down here. So we've got p squared minus 2p. And we just slip that term over to the c term to help us solve this. And 3 times 5, and we keep the sign, so that's negative, is 15. Okay, now we can just go ahead and solve it. Like any other trinomial, we think of two numbers that multiply together to get a negative 15, but add together to get a negative 2. So I've got p and p. Okay, and you can pause it and try and think of those numbers on your own for a few minutes. And those numbers are going to be negative 5 and a positive 3. Because negative 5 and positive 3 gives you negative 15, but a negative 5 plus 3 gives you negative 2. All right, now we've done the slip part of the equation. We need to do the slide part. We've got to undo what we did earlier. So we multiplied the c term by 3. Now we've got to divide this c term by 3 over here. All right, and if they simplify down perfectly, then you just leave it alone. So 3 divided by 3 is 1. So one of our terms is going to be p plus 1. Okay, and our other term over here, we can't simplify that down anymore. So we slide the 3 up in front of the p, and we get 3p minus 5. Okay, now we can check and see if we did it correctly by multiplying it back together. P times 3p is 3p squared. P times negative 5 is minus 5p. A 1 times 3p is plus 3p. And a 1 times negative 5 is negative 5. And we can see that negative 5p plus 3p will give me negative 2p, and so that's correct. All right, I'm going to do another example here. I've got 2n squared plus 3n minus 9. Okay, and you'll always check and see if there's a greatest common factor you can factor out to make your math easier. But in this case, there's not. There's nothing that 2, 3, and 9 have in common. So I'm going to go ahead and just do the slip and slide method. I'll take the 2 and multiply it by the 9, and that gives me n squared plus 3n minus 18. And now I just have to pick two numbers that I can multiply together to get a negative 18 and add together to get a positive 3. So if you want to go ahead and pause it and try and think of those numbers on your own, that would be great. We find out that that is going to be a positive 6 and a negative 3, right? Because negative 3 times 6 is negative 18, and positive 6 minus 3 is positive 3. All right, now we've got to go ahead and undo what we've done up here. I'm going to divide each side by 2, and see if I can simplify them down. 3 over 2 cannot be simplified down, so this is where I slide the 2 back up here. So I've got 2n minus 3. Over here, these do simplify down. 6 divided by 2 is 3, so that's just going to be n plus 3. And now I'll go ahead and multiply these out and check my answer. 2n times n is 2n squared. 2n, and this is the foiling method, right? So this times this times this. First, 2n times positive 3 is plus 6n. And now I do this one times this one, which is negative 3n. And negative 3 times positive 3 is negative 9. And I can see if I add plus 6n minus 3n, I'll get a positive 3n. So 2n squared plus 3n minus 9. And that's the same as what I started with, so we did it right. right, I'm going to do one more example here. I've got 9k squared plus 66k plus 21. All right, and once again, I'm going to see if I can divide out greatest common factor. And I just use my calculator a lot of the times and just kind of divide numbers out that I can see they have in common. You can factor these down and see which ones they have in common. And I found out that they all have a 3 in common. So I can divide out a 3, and then I'm left with, so 3 times 3 is 9k squared, plus, and then I've got 66 divided by 3, which is 22k, and then I've got 21 divided by 3, which is 7. Okay, so you'll just go ahead and solve this, kind of not worry about this guy for a little bit. We'll just bring him down as we go. All right, now I still have an a here, an a term here, and so I'm going to still do my slip and slide method where I take the 3 and multiply it over here by the 7. Okay, so that leaves me with k squared plus 22k plus 21. All right, now I'm going to go ahead and just factor like I normally would. I'll bring that 3 down again, and this is going to both be k and k to get the k squared. All right, and then two numbers that multiply together to get 21 but add together to get 22. If you want to go ahead and pause it and think of those numbers, you can. And that becomes, it's 21 times 1, right? Because k times k is k squared plus 21k plus 1k plus 21. And now we've got to go ahead and divide out the number that we multiplied at the beginning by the c term. We've got to undo what we did. So I'm going to divide each side by 3. And this is where I slide this up to the top here. So I'm going to have 3 times 3k plus 1. And then 21 divided by 3 is just 7. And that's going to be times k plus 7. All right, and here's the check for that last problem that we did. We're going to go ahead and multiply them together. So I'm just going to keep this, moving this 3 down here till we need it at the end. I've got 3k times k, which is 3k squared. Remember the FOIL method that we've learned? And then 3k times 7 is going to be plus 21k. And then 1 times k is just plus k. And 1 times 7 is plus 7. All right, bring that 3 down so we don't forget about it. 3k squared plus, I can combine those together, 21 plus 1k is 22k plus 7. All right, and now I'm going to multiply that out. 3 times 3 is 9, so I have 9k squared. 3 times 22 is 66, so I've got 66k. And then 3 times 7 is 21. And you can see I got back to my original problem. So we know that it's right. All right, thanks you guys.